Hi everyone, you are welcome to my class. If you are new to this channel, please consider subscribing for more interesting tutorial videos. So without wasting time, let's practice together. Okay, the first question says the values of x, y, z respectively in the expression m raised to power x, l raised to power y, and t raised to power 2 for the universal gravitational constant G are. So what we are actually asked to find here is the value of x, y, z. So when you see this kind of question, you should know this is dimension. So we are looking for the dimension of what? Of G. From there, you can relate it with this expression and get the value of what? X, y, z. So the only place we have gravitational constant is under gravitational field, where we have the law which says that the force of attraction between two bodies, let's say M1, M2, are directly proportional or is directly proportional to the product of the two masses and inversely proportional to the square of the distance apart. So mathematically you have F is equal to G M1 M2 all over R squared. So we're actually looking for G, which is the constant of proportionality. So from there, I will make G subject of the formula in terms of the unit of all these parameters. So I have G is equal to, when I cross multiply, I have F R squared, then M1, M2. So in terms of unit, the unit of force is Newton. So the unit of force in terms of derived unit, force is equal to mass times acceleration. That will be kilogram, the unit of mass, meter per second square, that of acceleration. So I'm going to put it here. I have here to be kilogram, meter per second squared. Then the unit of radius, the distance apart, R, is meter. So I'm going to have meter squared. Then all over, the unit of mass is kilogram. So I have kilogram times kilogram. That will give us kilogram squared. So in dimension, the dimension for mass is capital letter L. So since I have kilogram here, which is the unit of mass, so dimension of mass is capital letter M. This is meter, the unit of length, and dimension of length is capital letter L. And this is second, the unit of time, and dimension of time is capital letter T minus 2. And this is meter, the unit of length, dimension of length is what? Capital letter L. So I have L squared all over M squared. Is that clear? So that here I can have M, we cancel one M from here. I'll be left with L T minus 2 L raised to power 2 all over M. I can write it as L T minus 2 L raised to power 2 multiplied by 1 over M. And law of indices, 1 over M becomes M raised to power minus 1. Is that correct? So that I can rewrite this to be L T minus 2 L raised to power 2 M raised to power minus 1. So you see L like this shows that it's L raised to power 1. So I can add the power of what? Of L, since I have L raised to power 1 multiplied by L raised to power 2. That would be L raised to power 1 plus 2 to give me L raised to power 3. And here T raised to power minus 2. And here M raised to power minus 1. So if I rearrange it like this, I'm going to have M raised to power minus 1, L raised to power 3, and T raised to power minus 2, which is equal to M raised to power X, L raised to power Y, T raised to power Z. In that case, which implies that X is equal to minus 1, Y is equal to 3, and Z is equal to minus 2. So the option here, right, that goes with minus 1, 3, and minus 2. Minus 1, 3, and minus 2 is option C. Minus 1, 3, and minus 2, that is option C. So the correct answer here is C. So the next question. So the next question says, the diameter of a small ball bearing, thickness of a piece of paper, Roman figure 3, diameter of a measuring cylinder, 4, length of a piece of wire. Which of the above can be measured using a micrometer screw gauge? So the correct option here is Roman figure 1 and Roman figure 2. We use micrometer screw gauge to measure the diameter of a ball bearing and piece of paper, thickness of piece of paper. So next question. So the next question says, an aircraft attempts to fly due north at 100 km per hour. If the wind blows against it from east to west at 60 km per hour, you are asked to calculate the resultant velocity. So you start by writing down your 4 cardinal points. Here is your north. Here is the south, the east, and the west. So the question says it attempts to fly due north. Due north. So let's assume here is the 100 km per hour. So you also put your 4 cardinal point here. Here becomes your north, south, east, and west. So wind blows against it from east here like this to west at 60 km per hour. So at 60 km per hour. Are we clear? So the resultant is what? Is the line you draw from this point to this point. That is your resultant. So the direction is here. Remember, it's a vector quantity. So here is the direction, and here is the resultant, which is R with arrow. So since this is a right angle triangle, we are going to use Pythagoras theorem, which says that R square is equal to, if I name it, I don't need to name it, I'll just put the values, 100 squared plus 60 squared. So I have R is equal to the square root of 100 squared plus 60 squared. This is equal to that is 10,000 plus 6, that is 3,600. Okay, so I have this to be equal to 13600. So if I find the square root, that will give me 116.6. Approximately, I have 117 kilometer per hour. So that is the resultant velocity. So you can see from the option there's direction. So the next thing is to find your direction with respect to the starting point, right? So in that case, here is the direction. I put theta here. That is opposite over adjacent. So I'm going to have tan theta is equal to opposite is 60 all over 100. So I'm going to have tan theta is equal to 0.6. Then theta will be equal to tan inverse of 0.6. Tan inverse of 0.6 will be, that will give us 30.9, which is approximately 31 degree. And this is north of west. So the answer is going to be 117 kilometer per hour, north, 31 degree of west. And the correct option there is D. No, correct option here is north of west is A. You see, if you can get the answer, but if you mistakenly use different direction, you get it wrong. So be careful with this kind of answer. Don't be in haste, don't be in rush to pick an answer. Make sure you calm down and look very well before you select your answer. So the next question says, what is the acceleration between 2 points on a velocity time graph which has coordinate of 10 seconds, 15 meter per second, 20 seconds, 35 meter per second? To make this one as simple as ABC, just know that your acceleration is what? Change in what? Velocity. That is final velocity minus what? Initial velocity all over final time T2, assuming minus what? Final initial time T1. So from here, all this here, my coordinate here will be T1. Here will be initial velocity U. The next one here will be T2. Here will be final velocity V. So A now is equal to V, which is 35, minus U, which is 15, all over T2, 20, minus T1, which is 10. That will give us 20 all over 10, which is going to be 2 meters per second. I hope this is clear. So the correct option here is A.